Okay, class, so example 3.3, lesson 3.3, example 4. It says find the exact value of each expression without using a calculator. So we're going to use some rules that we know. Well, first we need to actually cover a separate rule here that some of y'all struggled with a little bit. It's something that you should have learned before, and so we had a little trouble. Remember, if you have a base raised to some rational exponent, which means it's a fraction, the top number is your little exponent and the bottom number is your root. So you could rewrite this as the root of your base raised to the exponent, and vice versa. If you're given it as a radical, you can change it back to be a rational exponent. So for example, if I have like x to the 1/3, well, my root, this here is my exponent, this number here is my root, and so I can write this as the cube root of x to the 1st. Or if I had like, let's say z to the 8/9, I can rewrite that then as the 9th root of z to the 8th. Or vice versa. If I had the 5th root of 2x to the 1st, I guess, we could rewrite that then as 2x raised to the exponent that's a 1 that's not written over the root, which is 5. Also be careful, because what if I had like the square root of x? Well, you have your base as x, your exponent out here is not written as a 1, over your root's not written, but remember, if it has that little symbol, that radical symbol, that's automatically a square root. So you can put a little 2 there if you want to, but you don't have to. So you end up with x to the 1/2. Alright, so after going over that, let's go back to that example we were looking at. Alright, so here we've got log base 7 of the 5th root of 7. If nothing else, I mean, there's all different ways to work this problem, but it's a log, so let's set it equal to y. Take it to exponential, so your 7 to the y equals the 5th root of 7. Well, we know that we can rewrite that 5th root of 7, so let me bring down my 7 to the y equals, it's my base, raised to, my exponent's not written, so it must be a 1 over the root, which is a 5. Then using that 1-to-1 property, the 7's are gone, and we know then that y is equal to 1/5. And since we set our log base 7 of the 5th root of 7 equal to y, then that means that's what it's equal to. Then on B, again, there's different ways you can work this. So the first thing is, though, I notice I have a log equals a log, a log plus a log. So therefore, we know using our properties that we can combine those. Since they're being added, we can combine them by multiplying. So I get the natural log of e to the 22 times e to the 5th. Well, then looking at what's inside here, we can use those exponent rules that we know. And because we have like bases, we know we keep the base. And what do we do to the exponents? We add them. So 22 plus 5 is 27. Now again, there's different ways to go from here. Most of y'all in class, they told me, oh, well, there's an exponent, so let's bungee it in front. So we can do that. So we get 27 times the natural log of e. Well, remember, you always need to check, can you work anything else out? Well, we've talked about what the natural log of e is equal to, but if you can't remember, we can say the natural log of e is equal to y. Remember, natural log has a base of e, so take it to exponential, and you get e to the y equals e to the 1st. Therefore, your bases are equal and y equals 1. So really what we have here now is we have that 27, and the natural log of e is 1, and 27 times 1 is 27. Hope this helps, guys.